Gentles and ladymen, I'm Spiro, and I'm not a wizard. Today we're going to embark on our journey of the Type-in program and kind of extend it into a little bit of the challenge that I alluded to in the last video. So this is video 3 in the series. We started out typing in a program from a game book, one of the early 1980s type-in program books, and the game we chose was called ICEBERG. You move your ship around trying to navigate the sea to avoid an enemy ship. The enemy ship can detect you and will move closer to you, but can't detect the icebergs. So the way to win the game is to trick the enemy AI into moving into a place where there is an iceberg. So what you can see on the screen is version 2 of our program. So we updated it, changed the colors, added cursor movement, changed it so that instead of redrawing the screen every single time you moved, it now only updates the characters that are being moved. So let's get my sip of my coffee because it's a little bit cold. I've got my Fairlight coffee mug at the moment. So that's cute, puts me in a 64 mood. Oh, so this wee game, the yellow Y is you and the red Z is the enemy. The blue cyan asterisks are the icebergs. So the player can move around north, south, east and west, so up, down, left, right. The enemy can move diagonally as well on the grid. So that makes it a little bit tougher, but we know that it's probably going to move diagonally toward us, which means it's probably going to move into this location here. So we could probably cheat by going, not really cheating, but if we move back again now, it'll move up. So we're safe. He's hit an iceberg and he's gone. So as you can see, this version, it takes a little while to draw the screen and the board. I haven't managed to find a workaround for that. So this is basically, he'll keep following you until he catches you. All right, so we took that code, which was pretty simple. Well, I took that code. There's been a bit of, we've had a few discussions on over on the Fediverse or Mastodon, and some fine folk on there have come up with some cool ideas that I hope they find the time to try and implement and try and play with. But as I was saying in the last video, this kind of gives us, the initial program had a really good enemy AI, and it was just really simply and cleverly implemented. So as we worked on it, we found, okay, well, we've kind of almost got the foundations for a sort of a roguelike. Well, it's not really roguelike because it's not automatically randomly generating dungeon floors or boards, but that kind of we've got the fundamentals for effectively like a top-down dungeon crawler like Rogue or like Gauntlet or something like that. And or as one of my previous videos where I did a playthrough, Catabatia, which I still don't know how to pronounce. So we've taken the simple iceberg program, and without changing any of the main logic, just extending it a little bit, I've come up with this, roguish. So I've now created a map, a dungeon map. The brownish, yellowish hashes are walls. The yellow @ sign is the player. The green ampersand is the enemy, and that's a goblin. And there's a door here. So the aim of this version is, without really, as I said, without changing much of the logic in the other game, we have now made a game that looks like a little dungeon crawler. It's an escape the enemy, just like the last one. There's no difference in that, but we've kind of made it look a whole lot cooler now, in my opinion anyway. So it's interesting now that the enemy AI, so in the previous one, if you hit an iceberg, then you died. If the enemy hit the iceberg, they died. So what I wanted to do in this version was, obviously you don't die when you hit the walls, you just can't go through them. So a few conditions have had to be added for the movement, but if I go down and I move around this side of the wall, you'll see now the enemy, he's still trying to follow me, but he can't go through the wall. But if I wanted to get a little bit further away, I can trick him. This might not be the best way to do it. Can I get away? No. I'm pooped. Oh, I haven't fixed that. See, there's still bugs in it, that is supposed to have shown up underneath that. But you get the general gist of it, right? The downside of this is that it is super slow to redraw. If I hit yes, and this isn't randomly generating, it is, I've got a big data section. Like, honestly, it was just so slow. I usually just hit warp mode, and get it to draw a bit faster. So it draws the map, and then it figures out, oh, see, I'm screwed now. And then it figures out the locations of the player, the escape door, and the enemy. So yeah, he's going to catch me because he can move diagonally. You can't escape. Oh, I see what's happening. See, it's just printing that wherever that was. That's fine. We can fix that. Let's go to the code. Here is the code. Now we'll take another quick little detour here. When I first started this channel, I was using, or at least when I first started using Commodore Basic inside Visual Studio Code, I was using a different extension. I was using one called Commodore Basic V2. That since started having some problems. So I found another one called ICEBERG. Now this is for a cross compiler called ICEBERG, but if you don't install the cross compiler, I just use it as syntax highlighting, and it's fine for that. Now the other sidetrack I wanted to mention was that if you notice the code here, I don't have line numbers in most of my code. I discovered a really cool feature of PetCat, and that is the program that tokenizes and detokenizes basic source code. And that is that if there is some code in there that doesn't have line numbers, it'll put them in. it starts at line 10 and then goes up by increments of 2. So I was like, cool. And I can indent code and it just removes those indents. It's great. So it's actually it has made it a little bit easier to redo this program. So the only lines that you need numbers for are ones that you're going to use for go-tos and go-subs, which is kind of cool. I haven't looked in to see if it features any way of doing labels. That would kind of be even cooler, but anyway. It's made it a little bit simpler. So here we go. I've got Roguish version 0.1 for the Not a Wizard Game Challenge, which I do invite you to consider joining in on. And the things that are a little bit different in here, for a start, the original code was, what it did was when it placed items on the board, the player, the enemy, and the icebergs, what it would do is it would wherever it's going to put them on the board, it would place in that array. The array was B for board, and in the XY coordinates, it would place a number, and that number matched the decimal PETSCII character code. So an asterisk, which was the icebergs, was a 42. The Y was 89, and the Z for the enemy was 90. So the game logic uses those numbers when it's doing collision detection and when it's drawing the board. So what I did is, instead of having the numbers scattered throughout and forgetting and always having to go back and say, what was 89 again, what was this again, what was that again, but also to make it easy so that I can change the characters if I want, what I've done is I've set up a few variables. One is PL for the player, and that 64 matches the @ symbol. EN is the enemy, and that matches the ampersand. WL is the wall, and DR is the door. So sets up the board dimensions, so 38 by 16. Now the other thing you'll notice in this, and part of the reason why it's slower than Iceberg, is that Iceberg prints the board, each column is separated by a space. So if your board is 16 wide, it'll actually take up 32 characters on the screen, widthwise. So, but because this is a bit more of a dungeon sort of crawler, then I wanted it to take up the full. So I've specified that as so each column doesn't have a space between. All right. So what we do is we set up the board. So we print the title at the top. We go through and we read the data statements, and then we set those data statements up in the board array. So what I've got is, if we go right down to the bottom, I've got a lot of data with ones and zeros. And what these are is because it's 38 characters wide, and because a line in BASIC can't be longer than 80 characters, and because these are got commas in between, if we go here, we're at column 45. I could probably have fit them onto one data line. I may still play with that, but effectively, if you think about 2 lines being 1 row on the screen, like that, so the ones will get translated as wall characters, the zeros will get translated as floor characters. So if we take these first couple of lines, you'll see that the whole top row, as you saw here, the whole top row is wall, and we've got 1, 2, 3, 4, 5 wall locations here. So we've got 2, 3, 4, 5 wall locations there, and so it continues. So I basically drew this out tediously, which is why it's pretty sparse. And that has, don't press Control Z too many times. Here we go, I think that's right. Okay, so that was how I did the map. So if we go back up to the top, it'll say if D, which is the number of the data that it read, is a 0, then the board position at that coordinate will be 0. So 0 in game terms means that there's nothing there for the player to collide with. If it encounters a 1, then it will place WL, which is the character for the wall at that location. So it goes through and creates that array. So that takes quite a while just to do that part. After it's done that, it'll then randomly figure out where the escape door is going to be. So it gets the door X and the door Y coordinates randomly generated. So the BX and BY is the board X and Y. But then what it does is it says, okay, but if those are already, if the location, if board DX and DY, hypothetically, if I allocated that, if there is something already there, so in other words, if the number at that location is not a 0, then go to 40. So it will randomly generate a new location. So it goes through the board and goes, I pick there. Oh, okay, oops, there is already something there. I better try again. I pick there, and then it'll be happy. And it does the same thing with the enemy start location and the player start locations. So again, generates a random location, checks is there something already there. And by doing that, what we've done is we've actually said, okay, well, the door location, we haven't put these, oh, that's an interesting point. I might have to look at that. I haven't actually, maybe technically I should be at this point going board DX, comma, dy equals, oh no, no, this is why I didn't do it, equals the door. Now the reason I didn't do that here is because the board gets drawn out first. I wanted the whole board to be drawn out without these locations being kind of visible. So that's why that isn't there. I haven't yet had a problem where two things are on the same grid coordinates. I might still consider whether I want to redo that. If I allocated the door here, it would mean that the enemy, if the enemy happened to be placed on where the door was already placed, it would have to find somewhere else, and then I would set the enemy on the board, and then once he's on the board, then the player would not be able to be allocated to a position that is occupied either by a wall, the escape door, or the enemy. So that might be a thing that I add. For these purposes, I haven't yet. So then it prints out the board. So it'll go through, it just prints a space here just to kind of center because it's 38 wide, the screen is 40 wide, it effectively just centers it. So you can see that it's a space in by where the text starts here. So it prints a space at the beginning of the line. Excuse me, I'm going to have some more coffee. And then it starts going through and printing the board. So as I said, at this stage it's only printing the empty spaces with blue dots and the walls with brown walls, hashes. And that's really, really, really slow, coupled with the generation at the random, or rather the data reading in, that's just quite slow. Once that's done, it'll print a message. I've got a little message printing routine which moves to the home location down past the board and then prints that on the screen, which obviously I didn't use for that because I'm an idiot. And then once it does that, then it prints, or at least it places the player, the enemy and the door on the board. And those are just simple little routines that I showed them in the last video, which is, we see anything starting with Z, I just use them for temporary variables. So the Z character has got the yellow screen code plus the character string for the player. It sets the player's coordinates, jumps to 250, and then that prints it on the board. So it goes to the home location, figures out, okay, your X location is here, I've got to go down this many lines. Sorry, your Y location, I've got to go down this many lines. Tab to indent in that number of places on the X axis, and then it prints that character that we specified. So it'll go through, it does that for the up here, the player, the enemy and the door. And then we get into the main loop. So this is where, and now it's indented, it's a lot easier to see. So that section of code is the main loop. Well, actually including that as well. It gets a key press. I've still left in the if they press north, south, east or west. I will take that out, and or it will check for the cursor keys, the up, down, left, right. What have we got? So the first thing it does is, after it receives a key, it sets the character to a blue dot, because it's going to presume that you and the enemy are both moving. So it goes through, gets your X and Y coordinates, gets the enemy's X and Y coordinates, and replaces them with a blue dot. If it so happens that you don't actually move anywhere, which can happen, so say for example you're against a wall and you move into the wall, you've done a move but you haven't actually moved anywhere. It will redisplay both of you later on. But first what it does is it replaces both of your characters with a dot, and then it updates your movements. So if you move south or down and you haven't moved out of the screen, and the grid you're going to move into is not a wall, then it will do that update. So we've got here y plus 1 because we've moved down, so we want to increase the y-axis. This is decreasing. Numerically it's lower, but we want the board coordinate to be 1 up. It does the same for the north. If you move up, the Y is opposite to that. X-axis does the same thing. So if the new board, so if it has moved you and your new location, so your X and your Y, has got a door character on there, then we're going to jump to 520 because the player is safe, they've reached the door, that's the exit. If your new location happens to contain the enemy, then you walked into the enemy and it caught you. Now, if neither of those happened, it's going to continue. So these are end game, and once it gets to those, so 500 and 520, 500 you're caught, it'll just show a different character on the screen at your location to show that you've been caught. You've been caught by the goblin. You go to 800. Oh, look at that. I probably want that happening before the game quits. That's funny. So yeah, it'll print you've been caught, and then it'll go to 800, which is the would you like to play again? And I need to fix that, don't I? Oh, bumsticks. I'll do that later. So otherwise, if it's not an end game, then the board location that it's figured out you've moved into is not a wall, it's not a door, it's not the enemy, so it's probably going to be an empty space. So we'll now put the player's character code in that space. We will put the enemy's current location at 0. Right, so we still have, so that you notice that we've updated the player coordinates, and we've checked if the player has hit stuff, and we've updated the player's location, but we've wiped over the characters on the board where we both are. So now it's going to say, okay, where the enemy currently is, we'll replace that with a 0. And now we're going to update the enemy coordinates. So what I did was I set up an NX and an NY. So for the new X and Y coordinates, and that is how I did the where he was following along. If you're on one side of the wall and you're on the other side, he will go up and down it. He obviously can't go through the wall, but still wanted to maintain that he was trying to follow you. So what we do here is we set up, we do the calculation to say to get the enemy closer to the player, and then we go through and we figure out if that is a valid place for it to be. So first of all, we check, okay, can it go to the new X and Y location? Is the new X and new Y a wall? If it's not a wall, then we're happy, so we can set both the X and the Y coordinates to the new location, and then we go to 180, which is we've accepted it. If it can't do that, it'll go down here and it'll say, okay, well, what about if we move on the Y-axis? So we'll check if the board location at the enemy's current X and the new Y is not a wall, then let's move there. And then if it's happy with that, it'll accept it. If it can't do that either, then it'll try and say, well, What about the x-axis? Can I try putting it on the new x-axis but keep the same y-axis? If that's not a wall, cool, move them on the x. Otherwise, the enemy isn't going to move at all. So that might happen, for example, if you're moving around here and he is in here, he may not be able to move on the x or the y axis, but he's not going to go that way to get further away from you. He's basically going to sit there while you kind of move around. But as you move up here, you'll notice, oh, he will be able to move on the y-axis. So he'll be able to move up. So it still gives him freedom without putting the game into an endless loop. So if I was to say, you know, try again, you know, in a different direction, then there's a potential for the game to be stuck in an endless loop. So, you know, let him try both. Otherwise, try one or the other. If we've got a new enemy location, we set it. First of all, we actually do another quick check to say if the new enemy location is actually the player, then he's caught us. So he will move after we do, and that'll another chance for him to catch us. Otherwise, the board location will be set for the enemy. We go sub 200 to 10, which is placing the player and the enemy on their new locations, and then we go back up and we wait for another key. And that's really kind of it. That is how it's done. So all in all, the main stuff that I've changed, other than the visuals of what characters are there, is I've added a preset board layout rather than having, you know, walls randomly placed. That would work if this was a like outside. For example, if they're wandering around a forest, I could have left the randomly generated iceberg code and just treated them as trees and said, you know, that just randomly dot trees around the board, and it wouldn't have had to go through all this. The other stuff really that I've added has mainly just been this stuff here that moves that adds to the enemy AI. This was the original enemy AI. It would move on the X and Y axes to move closer to you, and that was it. Check out the video in part 1 to understand why that is so clever. And yeah, that's kind of really it, you know. So I haven't changed that much. I mean, I've added a few extra characters. We've got an escape door, but you know, logically that's not any different to hitting an iceberg. It just so happens that this is not an iceberg and you win rather than losing, and that's kind of it. So I hope that is kind of inspiring. Like I'm what I would like to see is, you know, you use this as kind of inspiration to take this code. And this is on my GitHub. Links will be down below. You can download both the basic source code and the runnable PRG file. So, you know, if you're not interested in doing the code and you just want to play the game, then sweet, no problem. Have at it. You know, either take this version and modify it and do something more with it, or take the previous iceberg program and use that as your basis. Yeah, just some of the ideas, the comments that have been made on the Fediverse. So there's quite a few now, quite a few retro computing folks on there, and we had some cool discussions about this and some of the ideas of how to tweak the program and what could be done with it. One of them was kind of having like turning it into a snake game. One of them was turning it into a Pac-Man game, and again, you've got everything you need to turn it into a Pac-Man game here. You would draw out your board. You would have the enemy. You could have multiple enemies on the screen, and to do that, you would just, instead of having one enemy with their with their X and Y locations, you could just have an array, like we've done with the board. So you'd have an enemy array, that each one of them could do. And if you look at the original Pac-Man game, the different ghosts have got different AI. Some of them will move closer to you. Some of them just move around completely randomly, and some of them will actively move away from you. And that kind of can be a cool thing for you to try and play with here and see what can you do with this. What was one of the other ideas that we had, was kind of like a sci-fi game where you are you've got like a wagon train or something, and you've got to move it either across the screen and avoid some aliens, things like that. There's so much you can do with this, and that's why I started with this program, this ICEBERG, was because although it looked like such a simple game, and it is, it's deceptively simple, but also deceptively complex, and does give you so many of the fundamentals of developing games. Yes, it runs slowly and basic, if we use those same fundamentals and build, we could convert this to assembly. We could use all that exact same logic and just apply it in a different language. So it's kind of cool that something so simple can be such a good foundation for so much. I've probably rambled enough. How long is this video? Not one of my longest, but I hope you like it. Please join in. Please leave a comment below and let me know what your thoughts are. If you've got a GitHub, and you want to share your code on there with me and with the others, then please do. Or you could email me. If you go to the About page on my channel and you're not a bot, you'll be able to get my email address. If you're on the Fediverse, if you're on Mastodon, then or any other applications connected to the federated social media Fediverse, then my details are down in the description below. So yeah, no time frame on this. I mean, this is just for fun. Just if it inspires you, that's cool. My work here is done, and yeah, I'll see if we can make something else out of it. So I'll leave that. Thanks for watching. Thanks for your support. Comments and thoughts down below, and I'll see you in the next video.